Hey there! In today's video, we're going to be going over the 2022-2023 TMSCA General Math Regional Test. Let's do it. Alright, number 21. 2023 squared minus 2022 squared equals what? We're trying to find the answer. Alright, so we could take the long route of squaring 2023 and squaring 2022 and then subtracting them. However, this problem is in the formula of a squared minus b squared. It's in this shape or form or format. So what we can do is to solve a squared minus b squared, all we have to do is a plus b times a minus b. Alright, so let's substitute the values of 2023 and 2022 for a and b. So 2023 squared minus 2022 squared equals 2023 plus 2022 times 2023 minus 2022. Alright, so that's just 1. Okay, so we don't actually need this because we multiply by 1, that's just the same number. So all we have to do is 2023 plus 2022. And that is 4,045. And that's your answer. Next, number 22. What is the probability of rolling a pair of dice and getting a sum that is a prime number or greater than 9? Alright, when you roll a dice, there are a total of 36 possibilities because each dice has 6 possibilities. So 6 times 6 is 36. Now, each number, right, because there are certain numbers that you can get from rolling a pair of dice. Those numbers are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can't get more than 12 because if you get the max from each dice, which is 6 and 6, that's 12, which means you can't have 13. And you can't get less than 2. So these are the possible numbers. Now, for each of these numbers, there is a number that states how much, like what is the probability that they occur, or how much different options are there to get to that number. So for 2, there's only one option, which is 1 and 1 on the dice. For 3, there are 2 options, which is either 2 and 1 on one dice or 1 and 2. Even though it's the same numbers, it's on different dice. For 4, there are 3 options. For 5, there are 4 options. For 6, there are 5 options. For 7, there are 6 options. So you might think there are 7 options for 8. But from here, it actually starts going back down. So then 8 becomes 5. 9 becomes 4. 10 becomes 3. 11 becomes 2. And 12 becomes 1. So this is the amount of options you have to get to each of these numbers. And if you add all of these up, you will get 36, which is like the total amount. Alright, now the problem is asking, what is the probability of rolling a pair of dice and getting a sum that is a prime number or greater than 9? So the prime numbers here are 2, 3, 5, 7, 11. And the numbers that are greater than 9 are 10, 11, which is already circled, and 12. So that means these are the only numbers that fit the criteria. So let's just add up the amount for each of these. So 1 plus 2 plus 4 plus 6, and then over here plus 3 plus 2 plus 1. Alright, so 6 plus 3 plus 1, that's just 10. 2 plus 2 plus 4 plus 1, that's just 9. 10 plus 9 is 19. So we have 19 out of 36 total possibilities, and that's your answer. Next, number 23. 1 plus 2 plus 3 plus all the way to 18 plus 19 plus 20 equals what number? Alright, so this is a summation problem. That means that there's a series of numbers that are being added together and we have to find the total sum. Now we could just individually go and add each number, but that would take forever. It would take a very long time. So what we're going to do is we're going to use a technique called summation. So what summation is, you take the first term and you take the last term and you add them together. So in this case 20 plus 1, which is 21. And the reason we do this is, if you see the second term and the second last term, that's 19 plus 2. If you see, that's also a sum of 21. And if you keep going, it's always going to be 21. So no matter what, these are all going to be summed to 21. The first and last number, second and second last, third and third last, so on and so on. Now, 21 is not our answer because we still have more to do. There are pairs of numbers that add up to 21. So how do we find out how much pairs there are? Because that's how much copies of 21 there's going to be. Well, we can see that our thing starts at 1 and ends at 20. And it's going up by 1 each time, which means there's a total of 20 terms. So all we have to do is, if there's 20 terms, there's going to be 10 pairs because 2 terms make a pair. So we just have 21 times 10, which is 210, and that's your answer. Next, number 24. What is the measure of the complement to angle ECD in the picture below? Alright, so complement is just an angle when added to the other angle that makes 90 degrees. So this is a line, so let's just say this right here is your 90 degree angle. We already have, let's say, 37 as an example. That means the complement of 37 is just going to be the other number that adds to 90. So 37 plus blank, this is the complement, equals 90. So the answer to that is 53. So that means 53 is the complement of 37, and 37 is the complement of 53. Now, how does this relate to our problem? We're trying to find the complement of angle ECD, which is right here. But for that, we first need to know what ECD is. How do we find that? Well, we have this triangle right here called triangle ABC. So the triangle ABC always has a total of 180 degrees because all triangles have a total of 180 degrees. So that means if we already have 2 of the angles, we know that the third angle is just going to be the 180 minus the sum of the other 2, which is 83 plus 59. 83 plus 59 is 142. And 180 minus 142, that's just 38. So now we know that this angle right here, angle BCA or angle ACB, is 38 degrees. But we still don't know angle ECD. But actually we do. See, this right here is called a vertical angle. These two angles, angle ECD and angle ACB, they're vertical. That means that there are 2 lines intersecting like this. When 2 lines intersect like this, the angles on opposite sides like this will always be the exact same. So we have that same case here with line BE crossing with line AD, which means this angle, ACB, is going to be congruent to this angle, ECD. So ECD is 38. So now all we have to do is find the complement of 38, because that's ECD. So 90 minus 38 would get us the complement, which is 52, and that's your answer. Next, number 25. 25,861 equals what in Roman numerals? Alright, so for Roman numerals, you first need to know 2 things. What each Roman numeral means, and the rules of 4 and 9s. So each Roman numeral. So I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, M is 1000, and then V with a line over it is 5,000, and X with a line over it is 10,000. That's all you need to know for this problem. However, for the rule of 4 and 9, you need to know that because that's also very important. The rule of 4 and 9 states that instead of writing 4 as I, or 9 as V, I, you would write it as 1 before the next number. So for example, in the case of 4, that would be 1 before 5. So I before V. In the case of 9, that would be 1 before 10, or I, X. And the same thing happens when you go up in scale, so 40 and 90. 40 is 10 before 50, so you would write that as X before L. And 90 would be 10 before 100, which is X before C. Alright, now that you know that, we can solve this problem. So let's just break this problem into its place value. So we have 20,000, 5,000, 800, 60, and 1. So 20,000 is X, and both of the line over it, because that's 10,000, 10,000, 20,000. 5,000 is just V with a line over it. Like that. 800 is just 500 and 300. So D, C, C, C. 60 is 50 plus 10, so LX. And finally, 1 is just I. So now let's add all this together, which gets us X, X, V, D, C, 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 L, X, I. And that's your answer. Next, number 26. 444 base 5 equals what base 7? Alright, so to solve this problem, we need to go from 444 base 5 to base 10 and convert that to base 7. And we can't just go directly from 444 base 5 to base 7 because that's just not how that works. You always have to go to base 10 in between. So let's do 444 base 5 to base 10 first. So let's do that by writing as a digit. So that's 4, 4, and 4. Now, each of these digits by itself is going to be multiplied by a power of the base. The base is 5. So we're going to multiply this first 4 by 5 power 0. The second 4 by 5 power 1. The third 4 by 5 power 2. Alright, and then we're going to take the sum of all three products. So 4 times 5 power 0. Anything to the power of 0 is just 1. So that's 4 times 1, which is 4. Next, 4 times 5 power 1. 4 times 5 is just 20. So that's 20 here. Next, 4 times 5 squared. 5 squared is just 25. 4 times 25 is 100. So that's 100 here. So now we have 100, 20, and 4. When you add that up, that's 124. Which means 444 base 5 equals 124 base 10. Now we need to take 124 base 10 and convert it to base 7. Let's do that. Alright, now that we know what it is in base 10, let's convert it to base 7. The way we do that is by writing this number, 124, and listing the powers of 7, which is the other base. So 7 power 0 is 1, 7 power 1 is 7, 7 squared is 49, and 7 cubed is 343. We're going to stop right there though. We're actually not going to use 7 cubed because 7 cubed is greater than 124, so we don't need it. So we're only going to use these three powers. Let's do it. So first, we're going to start off with 7 squared, or 49. How much times does 49 go into 124? The answer is 2. 49 times 2 is 98. So we're going to write a 2 here and subtract 98 from 124. 124 minus 98 is 26. Alright, now, how much times does 7 go into 26? 7 goes into 26 3 times because 7 times 3 is 21. So we're going to write 3 there and subtract 21. And that leaves us with 5. Finally, how much times does 1 go into 5? 5 times because 1 times 5 is 5. So we're going to write a 5 here and subtract 5. We're left with 0 and we have 235 here. We're just going to write that as one big number of 235 and that's your answer. Next, number 27. So we have all these sets right here. We have 10, 20, 30, 40, 50. And then the symbol, which means intersection, with the set 5, 10, 15, 20, 25, 30. With this symbol, which also means intersection, 6, 12, 18, 24, 30. Alright, that is set A. So how much elements are in set A? Alright, this might seem like a confusing problem, but it's actually pretty simple. We're going to take the set at a time. So we have 10, 20, 30, 40, and 50. And we have this in one set, and that's intersecting with 5, 10, 15, 20, 25, and 30. Alright, so what this intersection symbol means, it kind of looks like an N or an upside down U. What this symbol means is the new set is created with the common elements from these two sets. So the common elements in these two sets are 10, 20, and 30. So that means this entire thing simplifies to one set of 10, 20, and 30. So now this entire thing over here has become 10, 20, 30, and that's being intersected with 6, 12, 18, 24, and 30. So there's only one common element here, and that's 30. So that means set A is just going to be 30 by itself. So now how much elements are in set A? There's only one number, so one element, and that's your answer. Next, number 28. Moving only left and or up. How many paths exist from point M to point N? Alright, so at each of these points right here where two lines intersect, from M, right, if we go up, directly up, and if we go directly left, there's only one way to get to each of these points on these sides. However, the amount of ways get bigger as we go up this diagonal in the middle. So let's do this. We're going to start at this point. There are two ways to get here because there's one way from this side and one way from this side. So two ways. And since you can only go up from here, there's only also two ways to get there. However, what about this point right here? To get to here, you can have the two ways from down here, and you have the one way from here. So there's a total of three ways here. Now let's go on to here. So you have the two ways from right here, and the one way from right here. So there are three ways to get here, and three ways to get here as well, as seen earlier with the 2 and 2. So how much ways are there to get here? Well, there's three ways from this side, and three ways from this side, which means there's a total of 6 ways on this side. And the pattern keeps going. So this goes up by 1, so 4 and 4. And this goes up by this number, which is 4. So 6 plus 4 is 10. So this is 10 now. Now this is 5 and 5. And this right here is 15. Now we have 6 and 6. And this right here becomes 21. Finally, right here, we have 7. And then to get to N, it's not just 7 again, because you also have 21 ways from right here. So there's a total of 28 ways, and that's your answer. Next, number 29. What is the geometric mean of the numbers 4, 8, and 54? Alright, the geometric mean is just when you take the nth root of n numbers product. So in our case, we have 4, 8, and 54. So what we do is we would take the cube root, since there's 3 numbers, of 4 times 8 times 54. And that would be our geometric mean. So 4 times 8 times 54. That is 1,728. So we're taking the cube root of 1,728. And the cube root of 1,728 is pretty easy. That's just 12. And that's your answer. Next, number 30. A motorcycle was clocked at a speed of 150 miles per hour. What was the motorcycle's speed in feet per second? Alright, so one common conversion you need to know for this test is 15 miles per hour equals 22 feet per second. That means if we're trying to find how much 150 miles per hour is in feet per second, we just have to multiply by the scale factor. So in this case, 15 times 10 gets 150. So to find the amount of feet per second, we would just do times 10. 22 times 10 is 220, and that's your answer. Alright, that's it. Thanks for watching. If you found this video helpful, please make sure to show your support. These videos take a lot of effort to make, and I would really appreciate it.